All right. So where should we, what should we do today? So we're still in the middle of chapter 14 here, and we're going to wrap that up today. And then we have some nice videos for you to watch. We're going to get some practice drawing graphs, very special graphs, and calculations of costs of production. And if we finish all that, then we may take a peek at chapter 15. But right now, let's get back to where we were. We started to introduce the idea of costs. Okay, so production and costs are basically the two sides of the same coin. All right, the more productive we are, the lower will be our costs of production, of course. So therefore, we do want to consider production, but we also need to especially consider costs of production, because ultimately this is what will determine whether or not our business is profitable. The bottom line is we have no control over how much of our product we can sell. So the revenues are always going to be somewhat out of our control, but the cost of production, that's something we can actually do something about. So as a business enterprise, you have some control over how much it costs you to produce your product. So what we're going to do is analyze the costs in this section of the chapter. And so again, we'll continue with our assumption that only labor is variable in the short run. So if we want to make more of our product, the only way to do that is to hire more labor. In the short run, we don't have time to acquire more land. We don't have time to acquire more capital equipment. We don't have time to, let's say, move into a bigger building. Right now, in the short run, all we can do is increase the number of people that work for us. So that will directly determine the cost of production in the short run. So we did mention that we have to make an important distinction here between what are called fixed and variable costs. All right, so in the short run, because labor is variable, every time we hire a new worker, that adds to our costs. And so because variable can be changed, labor would clearly be an example of what we mean by a variable cost. Okay, so fixed costs are the ones that do not change when the output changes. So for a microbrewery example, all the equipment that we needed to buy to start the business would be defined as a fixed cost. We only have to pay it once and that's it. We don't have to worry about that equipment again. And so the cost of the equipment does not depend on how much beer we make. It doesn't matter if we make none or if we make 1 million gallons a year, the fixed cost of the equipment is the same. All right, so altogether we have two different types of costs. And so our calculations will reflect that. And we also want to mention here that the proportion of variable and fixed costs depends on the industry. For example, you get very capital intensive industries like steel making or auto manufacturing or beer making, as we've just seen, where we have a lot of physical equipment that does a large percentage of the work and not so much human labor. And so in those cases, the fixed cost will be the largest percentage of the total and the variable costs will be the lowest. But then you also get industries where it's the other way around. Most of the work is done by people, like software. Okay, it's true that everybody needs to have a computer, but for all practical purposes, the work is being done by people. This is something that you can't obviously have done by robots like you can with cars and steel. So here you need people, and you're likely to have to pay them very well because this is a very lucrative industry. And the people who do create all the software, all these apps for your iPhone, they will expect to be paid very, very well. So in an industry like this, most of our expenses are variable. Now, once we define once we recognize that costs are either variable or fixed, we can also split them up in another important way. They can be defined as explicit, which means that they come out of our pockets, or implicit, which means that they're opportunity costs. Okay, so remember, an opportunity cost is the value of what you sacrifice when you use a resource for a particular use, because normally we would have had other things we could have done with those resources. And the value of those other things is what we mean by opportunity or implicit costs. And of course, we have to take all this into account when we determine how much output to produce. And it also helps us determine whether or not our business is profitable and whether we should think about maybe expanding it or possibly even closing it down. All right, so the explicit costs are the ones that we actually pay for out of our pockets. For example, the rent that we pay on land, the interest that we pay on capital, the wages that we pay to labor, those are all explicit costs because we have to actually pay for them. We have to actually write a check to acquire these resources. The implicit ones represent what else could we have done with these resources that we're using. Like, for example, here, if a building is being used to produce computer chips, let's say that this is Intel and they're running one of their factories that builds chips is actually owned by the company. They may have bought it because they figured it would be cheaper that way rather than renting it. And so they own this building. And the thing is, though, if they didn't use it to make chips, they could have rented it out to somebody else for $1 million a year. That being the case, the opportunity cost of using this building would be considered to be $1 million a year. That also means that if the chips that they're selling are not worth at least $1 million, then they would probably be better off closing down the factory and renting the building to somebody else. There's no point in working for less money than you could have earned just by renting out your facilities. So that's why this is such an important number. We have to ask ourselves, what else could we have been doing with these resources? And that's the only way we can allocate them efficiently. Now, of course, yes, we've already seen implicit costs are also referred to as opportunity costs. Now, this is about where we left off, if I remember correctly. We're going to start defining cost functions now. Now, remember, we did say that costs fall into two basic categories, fixed and variable. And so we'll simply define total fixed costs as TFC, total variable costs will be TVC, and then our total cost of production will equal the sum of the first two. Okay, because all costs are either fixed or variable, it stands to reason that our total cost of production will consist of total fixed and total variable cost. Now, like I said before, the proportion of each will vary from one industry to the next, but all businesses, virtually all businesses, have some fixed costs and some variable costs. Okay, it's extremely unusual to find a company that only has fixed costs or only variable costs. It's not impossible, it's just extremely unusual. Normally, there's a mixture of both. Now, this is important as far as it goes, but it's also important to be able to analyze how much it costs to produce each unit of our product. And one of the best ways to do that is by calculating the averages associated with these costs. And of course, everybody knows what an average is. If, for example, you're spending $1 million to produce 100,000 units of a product, then the average cost of production is $10 per unit. That's an important piece of information. All right. So let me just throw that in there as a quick example. Average costs are extremely important in determining how much a firm should charge for its product and for determining if the product is profitable or not. Okay, so as an example, if it costs $1 million to produce 100,000 units of a good, then the average cost of production is clearly $10 per unit. Now, why does that matter? Well, think about this. What if we're only charging $9 in the market for this product? Okay, that's a problem, isn't it? Okay, in other words, this means that if we can't sell the product for at least $10, hopefully more, then we should stop producing the product. Okay, it's not worth it. If it costs us $10 to make it and we're selling it for $9, that means we're losing money on every sale. So that would be a sign that something has to be done. We can try to raise the market price, or possibly we can find ways to reduce the cost of production. So we should stop producing the product. Well, let me add an extra section here, unless we can raise price or reduce the cost of production. Either way, we might be able to salvage this product if we can either raise the our revenues, but even then, we can't really be sure. It's going to ultimately depend on the price elasticity of demand if we can raise this price and still have more revenues. In other words, we can't be sure how people will react to a price increase, but one thing we can do is if we can reduce our cost of production, that guarantees that the product will be more profitable. And that's something we do control. We can't make people buy our product. We can try to, encourage them to buy it, but we can't actually force them to buy it. But what we can do is lower our own cost of production. Now, it's not always that easy. For example, what we might do is upgrade the equipment that we're using to make this product. Maybe we've got outdated equipment, and if we update it, that could reduce our cost of production. Or possibly we've got maybe not the most productive employees in the world, and maybe we should think about replacing some of them. Or there's a lot of possibilities. Or maybe we could move our facilities to another state, but that would be a long run. That would only happen in the long run, because remember, we're assuming that we're in the short run. Labor is variable. So anyway, here's the three averages that we would like to be able to calculate. The average fixed cost, the average variable cost, the average total cost. Down here at the bottom, we see that we also have something called the marginal cost. Now that's going to prove to be extremely important. Of all of these different kinds of costs, most likely this is the one that will be the most useful. All right, so what we have to do here is figure out how to calculate these values and then understand what they're telling us. All right, so what we're going to do now is see how these numbers are actually calculated. And also we're going to graph them all. And the graphs will make it easy to see the relationship between these different types of costs. We're going to use these cost curves a great deal throughout the rest of the course. We're going to need them very extensively when we start analyzing what are called market structures. So this will prove to be extremely important. All right, so why don't we start by looking at total fixed costs? All right, now, obviously that refers to the fixed costs that we use in our production process. These are the ones that are independent of how much we actually produce. So if you're looking at a Starbucks, for example, the machinery that's being used to make their products would be considered fixed costs. The coffee grinders, the espresso machines, the blenders, all the equipment that they have back there that they use to make the coffees, and the coffee pots themselves. I guess I should have thrown that in there. Those big urns that they have where all the coffee is made. Well, let me throw that in here. Okay, where they just pour in the coffee grinds and some hot water, and boom, they've got coffee. They're a lot faster than the ones you and I have at home, aren't they? Oh, yes, they are. They have to be. Those are commercial coffee urns. The fixed cost, it depends on whether we own the building or not. If we were paying rent on the building, that is also a fixed cost. That's a good point. If we own the building, we may have to pay property taxes, for example, and that would also be an example of fixed costs, because the amount doesn't depend on how much coffee we make. And that's all that it takes to be considered fixed. But that's a good point. Yes, the actual building itself, there could be other types of costs that we run into. There might be fees that we have to pay to the local government. There could be all kinds of things. But the bottom line is, if it's the same amount, no matter how much coffee we produce, then we call it fixed. Okay, so yes, the rent, if we don't own the building, would fall into this category. That would be true for every business, though. For Starbucks in particular, though, these are the types of fixed costs that they have that you might not get at another business. Okay, like obviously, Microsoft doesn't have to pay for coffee grinders. So this is something that's unique to Starbucks. But those are not the only costs that they face. When you run a Starbucks, They also have to pay for the products that go into the actual coffee, like the coffee beans. Obviously, you can't have coffee without coffee beans. You've got to have milk and sugar and cups. I added wages at the bottom, but this is something that's also, maybe I'll take that out because it's not unique to Starbucks. Obviously, wages. The more hours people work, the more coffee you can produce, but the more you have to pay for wages. So that's a variable cost, but it's not unique to Starbucks. So let me add this at the end here. So fixed costs that are common to most businesses include rent, property taxes, fees. Like for example, if you need a license to run your business from the local government, let's say that you're running a restaurant and you need a liquor license, most likely you have to pay for that every year, and that would be fixed. Variable costs that are common to most businesses include wages. Let's say, how about electricity? You probably, if nobody comes in the door, some of that electricity you have to pay for anyway. You have to keep the lights on, but the more you run those machines in a Starbucks, let's say, the more electricity you're going to pay for. What else could be variable? Wages. I don't know. I'll just put et cetera there. So anyway, but yes, there are certain things that are common to all businesses, and then certain items that are unique to each business, like these are unique to Starbucks. Anyway, so we bring these together and we determine that the total cost of producing our product is the sum of both, the total fixed and total variable cost. We have to take everything into account, and otherwise we're going to end up charging the wrong price for this product, or else we may end up going out of business because our costs are greater than we thought. Now, you may have seen, there are certain shows on TV that where, like, there's a series called Restaurant Impossible, which you may have seen. And basically what happens is the star of the show, Robert Irvine, he visits restaurants that are in trouble financially. And he tries to figure out what the problem is. And almost without fail, in these failing restaurants, it turns out that they're almost completely clueless about the cost of production in their restaurant. They don't know how much it costs them to buy the food that they're cooking. They don't know what price they should be charging. They just seem to be completely ignorant of how any of this works, which is kind of surprising because they're running a business and they don't seem to have any real understanding of how much it costs to run that business. And so that is a sure recipe for disaster. If they don't know how much it costs to do or make certain products, in the case of the restaurant, if they don't know how much it costs to make different dishes, how do they know what to charge for them? How do they know how much labor they can afford? How much do they, I mean, it's like you have to be right on top of these costs to run any successful business. So otherwise you're just asking for trouble. But anyway, now, of course, in those same restaurants, often the problem is that the food isn't very good. But still, it's almost always the case that the owners also don't seem to understand how their costs work. Okay, now we're going to look at the averages now. The averages are very straightforward because in each case, all we're doing is taking the corresponding total quantity and dividing it by Q, which represents output. So in other words, if I'm in Starbucks, and I sell 100 coffees an hour, then Q would be 100. Okay. So in other words, I'm trying to define the total cost, and I want to know how much that is allocated to each unit of the product that I'm selling. So the average fixed cost is just total fixed cost divided by Q, which is the total output. Now, what's interesting about this one is that since the total fixed costs are a constant, if I keep increasing Q, mathematically, what has to happen to the average fixed costs? Okay, so that's a puzzler for us to think about. Given that TFC is a constant, if I keep increasing Q, What has to happen to my average fixed cost? We have somebody who knows it has to go down. That's right. So when we graph this curve, you'll see that that's exactly what's happening. In fact, maybe I'll just show it to you right now. This is what your average fixed cost curve is going to look like. We're going to do these in a few minutes anyway. I'll spoil the surprise and show it to you now. With these cost curves, we always have dollars on the vertical axis, the amount we're spending. Q is the output on the horizontal axis. And the average fixed cost curve typically looks something like this. It just continues to fall as we produce more and more of our product, although in the beginning it falls very quickly and then it starts to level off a bit, but it will continue to fall forever as long as we keep making more of our product. So this is our average fixed cost curve. Now, as it turns out, this one will prove to be not the most useful of the curves. It's important to know how this works, but it's not going to turn out to be the most useful of all these cost curves. You'll see what I mean when we get to them. Okay, now, how about the average variable costs? I'm sure you can anticipate where this is going. We're going to take the total of variable cost and divide it by Q. Now, this is an interesting one because the total variable cost is not fixed. In fact, it grows as we produce more and more of our product. Now, because of the law of diminishing returns, in the early stages, when you're producing very little of your product, the total costs will tend to rise very slowly. But eventually, they'll start to rise more quickly. So the net result of that is that, let me show you this on the next slide. The curve itself has a very interesting shape. All right, so let me jump onto the next slide and show you what this thing looks like. Why does it keep doing that? All right, here we go. So what will happen is, and keep in mind, we're still in the short run. At first, the cost falls. Then when the law of diminishing returns starts to kick in, it'll start to increase, and then it'll continue to increase forever. So you can see it's falling at first, and then somewhere along the way, it bottoms out. And this is happening because the curve stops falling when the law of diminishing returns sets in. Okay, because remember how that works. At first, as we add more workers, their extra output from each worker is actually increasing very quickly. And that implies that the costs themselves are actually falling. Okay, so in fact, you know what? If you remember, like with the beer example, if we knew what the wages were of those workers, you could see that as we add more workers initially, each one is bringing more output to the table. So the cost of production, the average cost, that is, the labor costs, are actually falling at first. But then, unfortunately, when we hit the law of diminishing returns, then they start to go up again. And as they continue to increase, they'll never slow down again. That's it. So it's like a big U shape. That's normal. Now, it doesn't have to look like this. It is possible that it could be more like a straight line. Let's say, for example, it depends on what kind of cost you have, but In some very strange situations, it could be more like this, very flat, or it could even be a straight line. Okay, the one thing it won't do though is continue to fall forever. These are other possibilities, but the curve, this is the most common shape that you'll run into because that's how typically costs behave in the short run. And really, it's ultimately driven by the cost, by the law of diminishing returns. All right, now the last of the averages is the average total cost. And you can probably guess, well, it's just the total cost over Q. But algebraically, it turns out that we could also define this as the sum of these two. They both give us the same results. Okay. Now this curve actually looks very similar to the average variable cost curve. And that's because the total cost consists of variable and fixed costs, one of which is declining continuously and the other one which is increasing. So what I'd like to do is show you this curve by itself, and then I would like to show you how it compares with the average variable cost curve. Okay, so the ATC by itself, you'll notice it's very, very similar to the average variable cost. But what I would like to do next is show you how they compare to each other. And you'll notice some interesting things. Okay. So all right, so if I bring them together on one set of axes, what you'll notice is that while they have similar shapes, oh, one more thing, let me take a step back here. This is important for the graph that we're about to look at. Because of this relationship, algebraically, the difference between these two is AFC. All right, just keep that in mind when we draw the next graph. You'll see why this matters in a minute. All right, here we go. So if we bring these curves together, here's your average total cost curve. Average variable cost starts out directly below it. All right, I'm not drawing this well. I have to be very careful with this because what I want you to see is that okay, there we go. As I increase the output, if you notice, while they have very similar shapes, they're getting progressively closer to each other. So as Q increases, ATC and AVC get closer to each other. Now, the reason is because I mentioned just a minute ago, the difference between the two is the average fixed cost. And what do we know about the average fixed cost? The average fixed cost declines as Q increases. So this is why the curves are getting closer to each other, because the difference between them, which you can label right here if you want to, is getting smaller as Q increases. Okay, so in other words, before we saw that as Q increases, AFC shrinks. And so they get closer to each other. Let me add this because AFC gets smaller. So as I keep increasing output, these two curves will get closer and closer because they're separated by average fixed cost, which declines as Q increases. Now they'll never cross because the average fixed cost can't be negative, but they can get very, very close to each other. Now, this will prove to be really, really important in the next few chapters, because what we're going to end up doing is analyzing the cost of a firm and trying to understand how to determine where to maximize our profits. In other words, we have to decide how much of this product to produce, and that decision will depend on where can we maximize our profits, and that will come down to the relationship between revenues and costs. So these curves will prove to be extremely helpful in figuring out how much output we should produce. Now, I've saved the best for last, the most complicated of these cost concepts, but probably the most important as well. Okay. It is the one that will be proved to be more important than all the others, and that one is the marginal cost. Okay, so marginal, that has an extremely important interpretation in economics. The word marginal will show up everywhere, especially in microeconomics. In this case, it happens to be applied to costs. So we did see earlier marginal product. So we're already somewhat familiar with this notion of marginal. How does it work here with costs? All right, well, first of all, how's it defined? Okay, well, you can see we have these deltas here. Now, delta, as you know, is used to represent change. So what we have here is the change in total cost divided by the change in total output. So the difference here is these deltas. Marginal means the change in the word marginal just in general means the change in one variable with respect to another one. Here, we're looking at the change in total cost divided by the change in total output. Remember, Q represents how many units we're producing. So this one is going to be the one that really enables us to make big decisions. All right, so let me show you roughly what this curve looks like. And by the way, before I do this, let's go back for a second and look at the marginal product curve that we had earlier, way up here at the top somewhere. When we're looking at production, remember we had average and marginal products brought together. The marginal product curve, it goes up very quickly and then it falls as the law of diminishing return sets in. Well, think of the marginal cost curve as a mirror image of this marginal product curve. If the production is rising and then falling, that implies that costs are falling and then rising. So it's basically going in the opposite direction. So that helps account for the shape of this curve that I'm about to show you. And let's see what that looks like. And then we'll combine it with the other curves in a very important way. So the marginal cost curve, as I just mentioned, will first fall and then it'll rise very quickly. Now you notice it is kind of U-shaped, but unlike the other two curves, average total and average variable, it tends to fall fairly quickly. And then once it starts to rise, though, it rises very, very quickly. So that's what really makes it distinct from the others. It can really start to turn. And of course, the shape is due to shape reflects, as you can imagine, the law of diminishing returns. At first, when we hire the first couple of workers, their output grows very quickly, so the cost will go down. But once we hit the law of diminishing returns, then the costs of production start to rise again. And of course, you know what that means, though. It gets to a point where the cost of producing more and more output is very, very expensive. So, in a case like this, if you're producing way out here somewhere, the costs are through the roof. And so you would have to be able to charge a very high price in order to justify producing way out here on this axis as opposed to down here somewhere. Now, here's the interesting part. Look what happens when I bring these together. So we have average total cost, average fixed cost. That's no. I'm trying, as you can see, it's not easy to draw this. I want to make sure that they're getting closer together and yet still have that distinctive U shape. That'll do. The key here with the marginal cost is that let's see, let me try that again. What I'm trying to, let me put in these points. What I'm trying to do is ensure that the marginal cost curve cuts through these two at their minimum points. Okay, so that is the most important detail. While it falls at first and then rises, they intersect at the minimum point on each curve. Okay, so again, you'll see why this is so important in the next couple of chapters when we start looking at what we call market structures, but that's an important detail. The marginal cost cuts through each of these curves at their respective minimum points. So once we get past that point, you can see that from now on, ABC continuously rises and so does ATC. After this, it's all uphill, all right? And that's because of diminishing returns. So while these curves are fun to draw, we're going to get a lot of use out of them throughout the rest of the course. So that's why we want to spend so much time focusing on them. Okay, so I put here a small chart together where we can actually look and see how these costs are actually calculated. Just maybe to get a little practice, what we're going to do is go through and confirm some of these, but you should be able to fill in this chart on your own by the time we're done with this chapter. All right, so I've made up some numerical data for a fictional Starbucks. And all right, so let's see, how does that work? All right, so here's how it looks. So Q is output. Now this is Starbucks. Let's say this represents so many cups of coffee during an hour. Let's say the store is open all day, all night. And so every hour they sell a certain number of cups of coffee. The fixed costs are $30. And you can see they do not change. So these are all 30s. The total variable cost, which includes, of course, as we know, the coffee beans and all the rest, there's zero when we do not produce any output. Then they jump up to 20. So you notice how it goes up to 20, but then it only goes up to 10 by 10 more. From here to here is 20, then it only goes up by 10, but then it goes up by 15, 25, and 65. So in other words, what you're seeing here is the idea that at first the total variable costs rise very slowly, but then once the law of diminishing returns kicks in, it starts to go up very quickly. And then over here, you can see total cost, remember, is nothing but the sum of these first two columns here. So all of these numbers here are the sum of these two to the left of it. And because even though the fixed costs are a constant, since the total variable costs are rising slowly at first and then quickly, the same thing can be said of the total costs. Now, for these others, you'll probably need a calculator. Now, here at an output level of 0, we can't have an average cost because that would require division by 0. So just bear in mind, this one means total fixed cost over Q. This is total variable cost over Q. And this is total cost over Q. So basically, like here, this average fixed cost means 30 over 1. This one is the result of 30 over 2. All right, and you can see the pattern here. And it's going down continuously because you're always taking the same numerator and you're dividing by a larger denominator. So those are pretty straightforward, and you can see the pattern that emerges here. The numbers just keep going down. Now you can do the same thing with the average variable cost and total costs. In each case, you start with the appropriate cost column and you divide by Q. Okay, so let's see, just to avoid making it too cluttered here, I'll get rid of these little circles. When it comes time to calculating average variable cost, this 20 is the result of taking total variable cost and dividing by 1. This is the result of taking our total variable cost of 30 and dividing by 2. This one means I've taken 45 and dividing it by 3. Here I've got 20, which equals 80 over 4. And then finally here I have 29 equals 145 over 5. And so while if you notice, it falls at first, it sort of bottoms out, and then it starts to rise again and will continue to rise forever. All right. Now, average total cost, we actually have two different ways of doing this. You can use whichever one you want. So you've got two possibilities here. for example, this 50, you can see it's the ratio of total cost over 1. Q is 1 here. And this 30 is the result of taking 60 divided by 2. Okay. This 25 is a result of 75 over 3. This 27.5 is a result of taking 110 over 4. And this 35 is a result of taking 175 over 5. And that's great. And like the others, you'll notice it falls at first, and then it starts to rise. It's a U. But guess what? This time we have a second choice. All we had to do is add these two together. So these add up to 50. These add up to 30. These add up to 25. These add up to 27.5. And these add up to 35. So there's two different ways of getting at this number. And by the way, if you have ever used Microsoft Excel, you can see how this really lends itself very nicely to a spreadsheet. This would be the ideal application for a spreadsheet because you could, once you enter the Q's and the total costs, all the rest could be easily calculated with formulas. So if you know what I'm talking about, if you've used Excel, you know that this would be a breeze to set up in Excel. If not, we can do it by hand, but of course it will take a lot longer. All right, so I'll give you a minute to catch up, and then we really want to spend some time with the marginal cost because it's so important. Okay, so yes, let's hang in there. So yes, but yes, this is exactly the kind of thing that Excel is set up to do. All right, so I'm going to start erasing some of this stuff so we can focus our attention on marginal cost. Oh, yeah, I can leave these here. So the marginal cost of the first unit is the difference between the total cost. Let me use a different color. Compared with the change in the quantity. So here I've got plus 20, and here I have plus 1. And now that, by the way, that information appears here in this row. So this means the cost, the additional cost of making that first unit is $20. In other words, making no units was costing me $30. Making that first unit adds $20 to my costs. So the marginal cost of that first unit is $20. When I bring in the second unit of output, it costs me another $10 to make one more unit. And so therefore you can see the cost of the marginal cost of the second unit is $10. Now to make the third unit, my costs have jumped up by $15. I needed to spend another $15 to make that third unit. Now to make the fourth unit, my costs have jumped up by $35. So that brings me to 35. And then finally, the last or fifth unit, my cost jumped up by $65 in order to make one more unit. And that's where the 65 comes from. And just as we saw before, you notice the marginal cost drops, but then it starts to rise. And when it starts to rise, it really rises. It's going up very, very fast from here, 15 to 35 to 65. So that's why the curve is so steep. It really goes to the roof. Once we reach a certain point, it rises very, very quickly. All right. Now, I put these costs in. Now, Excel is great, but it doesn't always do the best job with graphs. So I tried to graph these in Excel. They're kind of clunky looking, but I'll show them to you anyway. They do look like what we did up here, although I think my handwriting graph is a little better. But if you plot these in Excel, what we're going to see is the following. First of all, we didn't actually do this ourselves. If you plot the total costs, you'll see that something interesting. The blue one is total cost. The red one is total variable cost. And this is total fixed cost. Now, the fixed cost is a flat line because it's a constant, of course. These two, though, are curves that are rising continuously as output increases. And the gap between the two is a constant of TFC. And because this never changes, the two curves will always be exactly parallel to each other. Although, again, it's hard to be sure. Excel, it's okay for graphs. It's not the best. But the two curves are rising continuously, and the spread between them is a constant, which equals TFC. Okay, so in other words, TC minus TVC equals TFC. And that's because initially we noted that the total cost equals TFC plus TVC. So algebraically, these mean the same thing. And this is the result. Now, it turns out this is not terribly useful. This is probably the last time we'll ever see these total cost curves, but it's important to understand what they look like. For our analysis of how to maximize our profits, it's really the average and variable cost curves, the average and marginal cost curves that really matter. These are just okay. They're going on in the background, but it's really the average and marginal that we really want to focus our attention on. All right, let's see. Now look at these. Now, yeah. Well, you kind of get the idea. The other thing too is the fixed cost. We often do not graph this on the same axis with the other three, because it's just so hard to see what's going on. It's kind of chaotic, as a matter of fact. So we're never going to do this. We're not going to have them all together in one place. I would say that this is really what you want to focus on right here. The two averages and the marginal. This is, forget average fixed costs. We know that they're on this graph. They're the gap between these two. But other than that, we don't normally graph it on the same axes because it's just not needed, and because it just makes things harder to analyze. So the Excel graph here is kind of clumsy, but just remember, this is what it's supposed to look like. All right. So with all that being said, it turns out we have a couple of interesting videos that will help us further understand what's going on here. All right, so let me get those out and send them off to you. And here we go. Let's start with number one. It's called Production and Cost Curves, Part 1. And so this will explain everything in great detail. And of course, the graphics are far better than what I can produce. So let's take a look at this. All right. Okay, well, that was pretty intense, wasn't it? But, I mean, he's just running through what we're doing, only pretty fast. But yes, we're definitely going to get some more practice with this stuff. It's not something you just do it once and you're done with it. So we'll definitely be getting more practice. But anyway, in the meantime, there's a second half to this that I'd like you to see. Let's take a look at this. All right, so here we go. Let's check this one out. Okay, I guess we're all done now. All right. Well, yes, that was just a very intense review of what we've already done, but well, you get to see the graphs, which is kind of nice, and you can see how they tie together. But so I posted on Blackboard a problem set for this chapter, chapter 14, problem set number one, as you can see, and it asks us to do a couple of things. we've got a total product function here, where what you're going to actually do is calculate the average and marginal products. And down here, we're going to, well, actually, we'll have a second scenario where we do the same thing after Starbucks acquires more efficient espresso machines. And then we're going to have this chart where you can fill it in with the different costs involved. I just want to point out here that we're assuming that capital is fixed, 10 units of capital. That will be your fixed cost. The labor is, of course, variable. That will be your variable cost. So when you calculate total fixed cost in this column, what you're actually doing is calculating the cost of capital. And just remember, it's never going to change. When you calculate the variable costs, what you're actually doing is figuring out the cost of labor. And then, of course, the total cost here is the sum of the first two. And after that, the rest of these just fall right into place. So that's what I want you to do here. So this is something that's, in my opinion, very good practice. And if you want to, you can take a shot at graphing these, because eventually you'll have to do that anyway. It doesn't ask you to do that here, but you might want to at least think about attempting it, because you want to get some practice with this. If you do, though, basically on one graph, you can have the total costs. On the other graph, you can ignore the AFC. We don't really need that. Just try to put all three of these together and just see what they end up looking like. So that's what I want you to do between now and Tuesday. And so it turns out that we're done with chapter 14. What's coming next? That's the big question. Well, we're going to dive into an area which is called market structures. And what we're actually going to do is look at the marketplace where all these different firms are competing with each other. And it turns out that in some industries, the competition is much stronger than in others. And so we want to analyze different kinds of market structures. Each one is what is separated by how much competition there is in that market. And so, for example, you've all heard of the word monopoly. A monopoly is a market where there's only one producer of a good. That would be one extreme example of a market structure where there's no competition. The other extreme, as you can see here, is something called perfect competition, where we have the exact opposite case where the competition is absolutely ferocious. And then we have an intermediate case, which is called monopolistic competition. It's sort of a hybrid of the two. So throughout those three chapters, we're going to spend a great deal of time analyzing these cost curves, and they'll help us understand how prices are determined in these markets and how we can determine what is the optimal output for each of these different types of structures. So you can see it's sort of like all one big topic here. That's what's going to follow up after chapter 14, which is done. So what I'd like you to do, like I said, between now and Tuesday, is work on this problem set, chapter 14 problem set, and fill in all the values. And I optionally try to draw a picture of these relationships, because it can help you very much in what's going to come up in the next few chapters. Now, it also turns out I have quite a few really interesting videos about these different market structures. And this is where we start diving into cases where we can actually look at real companies and try to understand what kind of markets they compete in and how they determine how much of their output to produce. So we can start to get into more of a little bit real world discussion, as opposed to all this abstract stuff that we've been doing. It's we're going to actually start looking at real companies after a while and try to understand what's going on with their what are they producing, how are they producing it, and how are they determining how much to produce. So it will be very, very interesting. Anyway, so in the meantime, I don't think there's any point in starting something completely new on a Friday morning. So why don't we stop right here, and I will see you all on Tuesday. Okay. All right. Unless there's any last minute questions, I think we'll call it a day. You're welcome.
Thank you.
All right. See you next time.